Today we're going to talk about two concepts. First is the midpoint. So when we're talking about a line segment and we want to talk about the point in the middle, the midpoint, and also talk about the distance. So trying to find the distance between 2 points, which we briefly talked about, but we'll also talk a little bit more in detail today. Let's start with the midpoint. So the midpoint of a segment is the point that divides the segment into two congruent segments. A segment bisector is a point, a ray, a line segment, or a plane that intersects the segment at its midpoint. So we would say that a midpoint or a segment bisector bisects, or in other words, cuts in half a segment. Take a look at example 1. In the skateboard design, VW bisects XY at point T and XT equals 39.9 centimeters. Find XY. Okay, since you know that VW bisects XY, that means that the point T, which is the point where it bisects XY, T is going to be the midpoint. Now if T is the midpoint, and you know that X to T is equal to 39.9, we can then find XY. So we would use the segment addition postulate, which we learned last time. XY, that entire length, is equal to XT plus TY. And since we know that XT is 39.9, and because XT is the same length as TY, we know that TY will also be 39.9. So substituting those, and we get that the entire length from X to Y is equal to 79.8 centimeters. Take a look at example 2. Point M is the midpoint of VW. Find the length of VM. Okay, you can see here in our diagram that our point M, which we're told is the midpoint, bisects our line segment VW. You can see that we've used tick marks here to indicate that VM and MW are equal to each other. We can start by writing an equation to solve. So, because we know VM is equal to MW, and we know that those are represented by 4x minus 1 and 3x plus 3, we can substitute for those in the equation. Now we can solve for x. So subtracting 3x from both sides, we get x minus 1 equals 3, add 1 to both sides, and we get x equals 4. Now, the question was not asking us to solve for x. It said find the length of VM. So since VM is 4x minus 1, and we solved for x, we can now plug in x equals 4 into the expression 4x minus 1. So this would be 4 times 4 minus 1, which is equal to 15. Now you also know what MW is equal to. It's also equal to 15. So although you're not asked for it, you should know and understand that because M is the midpoint, that both VM and MW equal to each other. So once you find the length of one, you know the length of the other. Take a look at example 3. Identify the segment bisector of PQ. Then find PQ. Okay, so what's the segment bisector of PQ? Since you have this PQ that's divided, and we see tick marks here, we see that PM is equal to MQ. That means whatever's going through PQ at point M is going to be our segment bisector, which in this case is line L. So that's our segment bisector. Now we have to find the length of PQ. Well, to do that, we need to solve for x. We're going to use the fact that PM and MQ are equal to each other to write an equation. So 5x minus 7 is equal to 11 minus 2x. Once you have that, we can add 2x to both sides, add 7 to both sides, and we have 7x equals 18. So x is equal to 18 over 7. Now, again, you're not asked to solve for x here. You're trying to solve for the length of PQ. What's the length of PQ equal to? Well, that would be 5x minus 7 plus 11 minus 2x. So we'll go ahead and add those together, and that gives me 3x plus 4. And now, since I know x is equal to 18 over 7, I'm going to substitute that into the expression here. So this is 3 times 18 over 7 plus 4, and if we simplify that, we get 82 over 7. So the length of PQ is 82/7. Now let's talk about finding the midpoint in a coordinate plane. Now, if you know the coordinates of the endpoints of a segment, we can use what we call the midpoint formula to find the coordinates of the midpoint. How do you find them? Well, simply put, the coordinates of the midpoint of a segment are going to be the averages of the x-coordinates and the y-coordinates of the endpoints. So what does that mean? Let's look at a picture. So the coordinates of the midpoint of a segment are the averages of the x-coordinates and the y-coordinates of the endpoints. So you can see here we have A and B, and we have the midpoint M. Now A has coordinates x1, y1, and B has coordinates x2, y2. To find the midpoint, to find the x-coordinate of the midpoint, you would find the average of x1 and x2, so x1 plus x2/2, and that gives you the x-coordinate of the midpoint. To find the y-coordinate of the midpoint, you would have to find the average of y1 and y2. So that would be y1 plus y2/2. So here's the midpoint formula. x1 plus x2/2, comma, y1 plus y2/2. Now the comma there is just to indicate that this is going to give you a pair of coordinates. So your midpoint that you're trying to get will have an x-coordinate and a y-coordinate. Take a look at example 4. The endpoints of RS are, R is 1, -3, and S is 4, 2. Find the coordinates of the midpoint M. So we'll use the midpoint formula. So x1 plus x2/2, so that's 1 plus 4/2. That gives us the x-coordinate of the midpoint. And then -3 plus 2/2, and that gives us the y-coordinate of the midpoint. Simplifying that, we get 5/2 and -1/2. So the coordinates of the midpoint are 5/2 and -1/2. If you want to write that as a decimal, that's fine. You can write 2.5, -0.5, that's fine. Let's do one that's similar, but just slightly different. Now in this case, you're told the midpoint of JK is 2, 1 at point M, and one endpoint is J, 1, 4. Find the coordinates of endpoint K. So in this case, unlike example 4, where you were given the two endpoints and you had to find the midpoint, now you're given the midpoint and one of the endpoints, and you have to find what the other endpoint is. Okay, well in that case, let's kind of work backwards. So if we're calling K one of the endpoints, we'll use the coordinates x and y to indicate the coordinates of K. And how do we find what x is equal to? Well, normally we would say to find the midpoint, you would have to find the average of the x-coordinates of J and K. So 1 plus x/2. We know in this case that's equal to 2. So we can go ahead and write a formula there. So 1 plus x/2 is equal to 2. So we can go ahead and solve, multiply both sides by 2, subtract 1, and we get x equals 3. We can do the same thing to find y. So we have 4 plus y/2 is equal to 1. And we can solve for y. So multiply both sides by 2, subtract 4, and we get y is equal to -2. So now you found the coordinates of K. So the coordinates of K are 3 and -2. So that's the midpoint formula that's applied to a case where you have both endpoints and to a case where you have one endpoint and a midpoint. The next thing we're going to talk about is the distance formula. Now the distance formula is a way to find the distance or the length of a segment using the coordinates of its endpoints. So last time we talked about how you can find the length if you're lined up on the number line. You can simply subtract one from the other and then find the absolute value. That still works. But say that you're working with something where it's not just on what we call the ruler postulate. Let's say instead you have coordinates somewhere on the coordinate plane. how do you find the distance between those points? Well, before we get there, we're going to have to go over a theorem that you've seen before, and that's the Pythagorean theorem. So the distance formula is actually based on this theorem, which says that if you have a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. So a squared plus b squared is equal to c squared. So how do you apply the Pythagorean theorem here? Well, let's say you have points A and B, x1, y1, and x2, y2, and you want to find the distance between them. What you can do is you can draw your own right triangle, like we have here. Find the distance between the x-coordinates, find the distance between the y-coordinates, and once you have those, you can apply the Pythagorean theorem to find what lies along the hypotenuse, which happens to be the length or the distance between A and B. So AB squared is equal to x2 minus x1 squared plus y2 minus y1 squared. Now you'll notice here that I've dropped the absolute value signs, and the reason for this is once you've squared it, it's always going to be positive. So there's no need to take the absolute value first and then square it. A negative number squared and a positive number squared will end up being the same thing. So in order to actually get the distance from A to B, all you would have to do now is just to take the square root of both sides. So in the coordinate plane, the distance d between 2 points x1, y1 and x2, y2 is given by this formula. D equals the square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. Now anytime you square it, please be sure that you are getting a positive number. If you are putting this into the calculator, just be sure that whatever you're squaring is in parentheses. Let's look at example 6. Find the distance between points A, which is at 1, negative 3, and B, 2, 4. I'm going to start off by calling point A. I'm going to start off by saying that 1, negative 3, that's going to be x1, y1, and 2, 4, that's going to be x2, y2. Now, if we are to apply the formula, here's the formula. You have 2 minus 1 squared plus 4 minus negative 3 squared. All right, so we have 1 squared and we have 7 squared. We add those together before taking the square root. And so we get the square root of 1 plus 49, so the square root of 50. Now we can simplify that. We can pull out a perfect square here, square root of 25, which is equal to 5. So this is equal to 5 root 2. So the distance between points A and B is 5 root 2.